Not yet, sir. Not yet. So I'll just introduce and pass on the sharing to you.
Okay.
Uh, so welcome everyone to this free masterclass on analog and power management IC design. This session is being organized in collaboration with Office of the Principal Scientific Advisor to the Government of India, along with DRIIV, Delhi Research Innovation and Implementation, and Indian Institute of Technology, Delhi Center for Automotive Research and Tribology. So I have with me two very eminent faculty members from IIT Delhi who will be taking this session today. My name is Sumit, and I'll be your host for today's session. So before we take this session ahead, as you could see the title on the screen, this decade will be the decade of semiconductors. So this session has been organized to highlight the immense career opportunities which are coming up in the semiconductor industry in the coming years. So why this particular masterclass is being organized? So I wanted to take a few words on this. So if you look at Q3 of 2023, we saw a 30% global capability centers which were set up in India were in the semiconductor space. That highlights how world is seeing India in the age of semiconductors. So we have planned a course program and this masterclass to help you understand, and we want you to be ready, explore this semiconductor industry as a career opportunity, where there is going to be a 40% rise in semiconductor jobs for electronics and electrical engineers. We would like you to understand about this $10 billion semiconductor industry, which is in building currently. We would also like you to understand the emerging technologies in the semiconductor domain. So I could see many of you are already working in this space, yet there are many new opportunities which are shaping up, which Dr. Santanu Misra and Dr. Mandeep Singh will be highlighting in the presentation today. Going forward from here, this masterclass and the course that we have designed under the aegis of IIT Delhi and DRIIV is for electronics and electrical engineers. So professionals who are looking at building up their expertise in IC design and specialize in analog and power management circuits. This masterclass is meant for semiconductor industry professionals, engineers and technicians who are already working in this semiconductor industry and looking to upgrade their skills and advance their careers by a specialized course. This masterclass and this course will also make a lot of sense to fresh graduates in electronics and electrical engineering or related field who are aiming to enter the semiconductor industry. We've designed this program for design engineers, research and development engineers, technical leads, and even managers who are looking at building up their career in this emerging industry. About the stakeholders, I would like to share a little bit introduction. So this course that we have formulated is in pursuit to strengthen the government of India's impetus in building a semiconductor industry in India. So government, academia and industry have come together to build a relevant talent pool for this rising semiconductor industry. So this course has been constructed in close collaboration with IIT Delhi. Dr. Santanu Misra and Dr. Mandeep Singh Rana have formulated the course program and the outline in close collaboration with Delhi Research Implementation and Innovation Initiative, which is under the aegis of Office of Principal Scientific Advisor to the Government of India, Science and Technology Cluster. So this Science and Technology Cluster initiative under the Office of Principal Scientific Advisor has been formulated to create impetus, thrust, push in various emerging technologies. So this is the motto of PSA office, and Delhi Research and Implementation and Innovation Initiative is implementing the motto on actual ground level. So all the industry coordination, industry relevant push initiatives are being planned by DRIIV. And IIT Delhi, being the academia, forefront of the academia, brings experts like Dr. Santanu Misra and Mandeep Singh Rana to bring in the relevant skills to build employable talent pool. I, Sumit Kanu, represents Railway Academy. So we have partnered with these stakeholders to take this wonderful program to right audiences and youth. So we are marketing this particular program with these stakeholders to ensure that more and more talented engineers become part of the rising semiconductor industry. Going forward, we have formulated an online 6 months, 60 hours executive program in analog and power management IC design, in which we're looking at training young engineers, working professionals who are looking at building or growing their career in the semiconductor industry. So we'll talk about the program. Professor Santanu Misra and Dr. Mandeep Singh Rana would be talking about the program, its curriculum, how this program differentiates, and what career opportunities unfold after you finish the program. So I would like to introduce now welcome both of our faculties, Dr. Shantanu Misra and Dr. Mandeep Rana from IIT Delhi, to start the session. So welcome, sir, and over to you now, sir.
Okay, right. So let me share my screen.
Sure, sir. Let me stop that my screen. Thank you, sir. Yeah.
Are you guys able to see my screen?
Yes, sir. It's visible now.
Okay, all right. Let me just minimize these. It's okay. So before I even start, let me justify the content of the course by telling you where it comes from. Okay, so I am professionally trained as a power electronics engineer, actually. Okay, so at IIT Madras, when I was a master's student, I was actually in energy systems. Okay, then when I went to University of Florida, I worked on power management converters. So I'll talk about power management converters. So now, during this time, I got exposed to this concept of analog and power management IC, and because of this exposure and my research there at the University of Florida, I got employed in this company called Infineon. Okay, so where my job was to define and design power ICs. That was what my job was. And when I came back to India, that is what I wanted to offer to our students. And as we went along, Mandeep, Professor Mandeep, who is with us, he kind of enriched the course with his experience in he was an engineer at GE Global GE Aviation. So he enriched the material of the course. So what you will see from this course is that this course we are not IC traditional VLSI designers, okay, or the VLSI professors. We are power electronic professors. And we have been working on power electronic research and product development for about 20-25 years, me, and about 5 to 10 years for Professor Rana. So you will see that what we will be talking about is idea of power management IC and analog IC from a power engineer point of view. Okay, not from an IC designer point of view, from a power engineer point of view. So why am I stressing on this fact? The reason I'm stressing on this fact is because I have a sincere belief that if I can understand, anyone in the world can understand. The reason it is true is because actually I am the dumbest student in the class. So if I can understand, everyone can. So when I was a student in power engineering, I always viewed IC design as a very difficult subject. And when I learned about it in Florida, and then later on in my experience at Infineon, I realized that actually they are very logical extension to what power engineers do, right? So that is precisely what we will be doing in this course. So I'll just have few slides. I will go through it and then I will take up your answer. So I just wanted to give you a context of what we'll be discussing in this course. Right. So let's go to the next slide. So if you look at power electronics, okay, so power electronics is applied almost anywhere where you have to transform one form of power to another. Let it be solar energy, let it be data centers, let it be EVs, normal cars, let it be battery energy storage system, let it be EV chargers. I'm talking about all this because that is what I right now do as a part of my daily life, because being in Center for Automotive Research, these are the things these are the research I kind of carry out with industry. But said that, it is also true that this power, the application of ICs, like power ICs, are also there in all kinds of electronic devices, gadgets, like for example, phones and uh, you name it, it is there. Whenever you have to transform power from one form to another, you will require a power converter. Okay. So the applications are from megawatt level to milliwatt level. So if said that when you talk about a power converter, there is a source and there is a load. So there is a power converter in between. So traditionally, when people talk about power converters, they talk about DC to DC converter, which is like an example of DC to DC converter is your phone, right? So let's say a Qualcomm processor, a Snapdragon processor will require a 1.2 volt or 1.8 volt fixed DC voltage, and that voltage will be supplied from a 3.3 volt or 3.8 volt battery that your cell phone has, right? So this conversion is taking through a DC to DC converter. That is a watt level, smaller power level DC to DC converter. A bigger power level will be, let's say, solar charging. So we have a solar farm which is generating hundreds of kilowatt, and you have to charge a battery using that, a BESS, the battery energy storage system. So that is an example of a high power converter. Okay, so that is an example of a DC to DC converter. Similarly, DC to AC converter is inverter. Inverter you have in your home, you have a DC 12 volt battery and you have a 230 volt generated from it. So that is an example of an inverter. And rectifier is your cell phone charger or your laptop charger. You are taking AC power and giving power to a DC battery, right? So that is the example of a DC to AC to DC converter. And AC to AC converter is actually in modern context, it is not a converter at all. It is actually a rectifier and an inverter connected in cascade. So an example of that will be your washing machine, right? Washing machine takes AC, it takes power from the AC grid, like 230 volt AC grid, and it is actually driving the motor, which is rotating in clockwise, counterclockwise, all those whirlpool it is creating, right? So that is an example of a AC to AC converter. So it is basically a rectifier and an inverter connected in cascade. But when you talk to like when we teach power electronics to like as an undergraduate subject, we distinguish these things. Okay, but for you that distinction may not be required because you have come to a IC design course. So this distinction of whether it is a rectifier or a converter or an inverter, it is not there. Why it is not there? So that will be clear in this slide. The reason is that every converter, no matter it is converting from DC to DC, DC to AC, AC to DC, it doesn't matter. And at what power level also, it doesn't matter. Every converter has two main building blocks. And there is a third building block, which will be called a sensing block. So let me go through this building block. So first building block is the power stage. Power stage is the one that is the muscle that is transferring power. Okay. So when we are saying that a 100 kilowatt converter, a 100 kilowatt of energy is being transferred, 100 kilowatt of power is being transferred from the source to the load. So that will be called the power stage. So that will consist of inductors or magnetics, or to be specific, magnetics, capacitors, heat sinks, switches, PCBs, etc. Right. So these will be designed to carry that 100 kilowatt. Now, when you are saying that I will transfer this 100 kilowatt, then the second question will be at like what will be the rule of transfer? Like for example, if you are charging a laptop battery, which has to be charged from a 230 volt. So now your V input becomes your 230 volt and your output becomes your laptop battery. So now laptop battery is about 19 volt. So now what is the rule of engagement? That means what is the rule under which power will be transferred to this 19 volt battery? So that rule will be decided by this control stage. So control stage is basically the brain of the converter. So control stage regulates and controls the power that is being transferred from V input to V output. For example, in a laptop charger or your cell phone charging, you have CCCV mode. So constant current or constant voltage mode. So you must have realized that your battery, your cell phone battery or laptop battery charges from, let's say, 20% to 80% very, very fast. And after 85%, it is actually slow. The reason is that from when we are charging from 20 to 80%, it is actually charging with a constant current. So this control stage will decide how the power stage will become a current source, right? CC, constant current source. And then after 85% of battery charging, the control stage will automatically make this power stage a voltage. So the control stage is actually the brain of the converter. And the power stage carries power. Control stage is the one that is actually taking signal from the power stage through things called sensors, voltage or current sensors. And based on that, it is deciding how to control the power stage. Now, in these three building blocks, the one that will be easily adapting to a IC will be the control stage. The reason is that it is an electronic circuit, right? So in this particular course, what we will learn is how do you define these control stages for a power converter? And you may be thinking that for an inverter, this control stage will be different. For a rectifier, the control stage will be different. Yes, it will be different. But the idea is that there are fundamental ingredients. They just have to be connected in a certain way inside the control stage to realize this controller, right? So now once we have done that, then then Professor Mandeep will in a few minutes talk about how do we take from this definition of how the control stage looks like to an IC. That he will basically take over in a few minutes. So now if you look at a control stage, it is actually getting a sense signal from the power stage. And why do you need these sensors? Because the power stage is working at a very high voltage, like 230 volt, 380 volt DC, like for example, in a EV, 380 volt DC. So these voltages are not that much adaptable to the control circuit. Control circuit generally works at VCC VSS level, right? VCC VSS is maximum 15 volt, 5 volt, 3.3 volt, 5 volt, 15 volt, 12 volt, something like that, very low voltage. So you cannot just simply put a very high voltage into the control circuit. You have to go through certain protection circuit and certain sensing circuit before you can interface the power stage to the controller, right? So that is why these sensors are required. So in the course, what we will do is that we will give an example of a complete circuit. Then from there, what we will do is that we will slowly go towards the controller and tell you what are the blocks there in the controller. Now, how do you design the blocks so that the power stage control objectives are kind of satisfied, right? So this is an overview of what we will do. So there is a sensing signal coming from the power stage, which will be taken by the controller. It will process the signal. So this processing will be done using an analog control. In this particular course, we will be concentrating on the analog control. And then it will generate some PWM signal which will be driving the power stage. So this PWM signal is basically driving our power stage, right? So now so the sensing signal takes the signal from the controller. From the power stage, and that is processed by this control circuit. What is inside this control circuit is what we'll be learning in the course. And like how does one control circuit differ from another control circuit also will be obvious to you. Then once you have done that, how do you make an IC out of it? How do you know that what pins should be there in the IC? Because once we have defined the controller, how do you know which pin to get out and which pin not to get out, right? So that we will kind of see. And then once it has been done, then how does that interface with the power stage so that the overall control objectives are kind of obtained. So it will not be a control system course. It will not be a power electronic course. Power electronics will be used just to make you understand what the controller is doing. Control system will be used just to make you realize that what the control objectives, how they can be made. So with this, we will be mostly concentrating on the control IC aspect of it and how to define and design this IC. So with this, most of the companies have a portfolio of power management IC, let it be TI, ST, Infineon, others also. So we will be learning what, like once you take this course, you will be very easily understanding what this power management IC portfolios are and how they are basically designed, etc. So with this, I will just request Mandeep to kind of take over and go through the next few slides.
Yeah, thank you, sir. So, am I audible? I hope.
Yes, you are.
Okay. So, just to start with, actually today, whatever the discussion is just an introductory discussion. So, I thought it is really appropriate to include what we will talk about in this course and what we will not. Because the expectation as well as the utility where it is being used is to be very, very clear. So, I mean, most of us who are working in the industry knows about the manufacturing process. But just to make it a familiar discussion for all, usually how do we make an IC or a silicon chip, basically? So, first of all, certainly there is an extraction of silicon. It is also a multiple step procedure. Then it is being melted and purified. Many extra gases and elements are taken out. And then it is again solidified into purified silicon cylinder. Later it is cut into small wafers, like the disc which I am showing, similar to that. And then we implement the circuit which is to be implemented over there, like the last figure shows. And these circuits are being the part of the inside of the IC. From there, we take bond wires and connect them to the external pins and all. But when we do that, we actually have to build a particular layer by layer, a 3D structure into this wafer. So to our eyes, it looks very thin, maybe hardly 1 mm, 2 mm size, but it is very, very thin, and they are actually going to build even thinner, very, very thin, like micron nanometer size structures, which are going to build upon it and perform the IC function. But this total work comes under the manufacturing. This is also one of the IC design or VLSI sort of, I would say, area, but we are not actually going to focus in this particular part. The next page, please. Yeah, Shantanu sir, please next. Yeah, thank you. So what happens is this whole IC, whatever we are talking about, has a background design which has to be implemented on this particular disk wafer, as I said, silicon disk. That sort of design is again very sort of physical in nature, like where we have to put N region, we have P region, where the conductors, where we have to diffuse the things. So there are multiple steps to implement that also. Again, this is not strictly into the manufacturing zone, but it is very much tied to the manufacturing zone, where an engineer who is familiar to this technique would sit and plan the circuit which has been given to him into this format. And there are many softwares which help, but this is certainly the part where we have a circuit, we have a design, and we want to implement that design into an IC. Now, if we talk about this side of story, which is manufacturing and the device level study, this is also part of VLSI design or analog IC design, I can say. But this is not we are talking about in this course. Reason is uh, this is strictly confined to a very limited space of the, I would say, design procedure, because it is ultimately implement of the design into a manufacturing technique rather than designing an IC. So other way, I would rather say on the right hand side, what I am showing is an IC, and there is a block diagram associated with the IC. So I would rather focus a little bit here. So what happens whenever we talk about an IC, there is a pre-manufacturing step. That pre-manufacturing step is to achieve that particular design from standard gates or standard MOS technology, or earlier it used to be BJT technology, but nowadays we do FET sort of design. So every IC has several blocks in it. More or less, many of such blocks are needed to make an IC, and these blocks are used as a fundamental building block. It's like very similar to brick. So if we know a brick, we know how to put a brick, we can certainly make a wall, and then we can make the building as we require. So same way, there are different kinds of blocks or the bricks, building block of an IC, which we arrange and put in a particular IC to make it functional. So what we are going to do is we are sort of going to learn this each of these blocks. So if we look inside this block, let's say we talk about, let's say, first part, which is charge pump. What is there inside a charge pump? How to design a charge pump? What sort of circuit it contains? And what are the broad perspective of the design? So there is always, as we all know that in VLSI design, there is always a possibility of studying the device physics, going through a lot of analysis. This is not we are talking about. Right now, in this course, we are majorly talking about the design guidelines, so to say, or engineering perspective. Let's say I want to design a charge pump. I have certain specifications. So then from that specifications, that requirement, how do I go towards a design or a circuit or sub-circuit which should be put in place of a charge pump. Similarly, like bootstrap charger. So there are many such blocks. So one by one during this course, we will learn each of these blocks. And once we know each of these blocks, then we will finally combine these blocks to talk about a function of an IC. So starting from very basic op-amp to the higher level ICs, we will talk about how to design them, and then based on the specification towards this design, what are the steps are needed when we connect them. So the next procedure, which is from this block diagram to realization of this hardware part into the fabrication IC itself, this is not we are going to cover in this course. This course is totally focused on this implementation and their intricate circuits. So basically, this is one area which is required by most of the industries, because manufacturing side in India, very less industries are there at present. But pre-manufacturing, the design side, and even uh, as far as the utilization of the IC, utilization of the part of IC side, many industries are requiring and many industries are using actually the engineers. So this is where we are focusing in this course. If we know an IC, we know its function. So how to get to the block diagram from that function, and then from that block diagram, how to implement that particular IC in a circuit format using very basic MOS circuits. And what should be the properties of those MOS circuits, like what should be their physical parameters, which sort of MOS we will be using, how we are connecting and all. So from this point, I would transfer to Santanu.
I'm glad that Mandeep, you showed this picture, because this picture basically summarizes what we will do, and very nicely summarized. So this is a switcher, right? So this is a buck converter. So like, what is a buck converter? We'll do that. Now, for a buck converter, what can be an IC to control a buck converter? So this picture is actually giving you an idea what is inside an IC to realize this buck converter, and when can you realize and when can you not. Like, for example, they're putting the switches here. So that means this switcher is for very low power, because the switches inside cannot carry a lot of current, right? So and then once we have done that, like Mandeep just mentioned, that each and every control circuit, why they have been connected in this way, why not in some other way? So that will be very logical to you once we tell you that these are the 1, 2, 3, 4, they have to be connected in this fashion so that the controller can be implemented. Then like Mandeep also said, that once we know that, then what is inside this controller? Right. So that also we will go up to that point. We will go. So we will use what Professor Rana said, that we will go through the MOS procedure, like but like, for example, in certain cases, like for example in op-amps, we have to use BiCMOS. And why do you need to use BiCMOS processes there? So these are some of the things that we will basically kind of cover one by one. So I'll just quickly complete the presentation so that we can take some more questions from you. Who should take the course? Like Sumit already mentioned, that industry professionals who are interested in power management IC part of it. What are the crux of power management IC? Because see, this power management IC group always, like in my time, they were all VLSI designers who were trained in power electronics. So I was one of the very few engineers who was from the power engineering who learned VLSI, right? So that is what you will kind of see when you talk to me, and you will understand that my knowledge of VLSI is more from a power engineering perspective. And UG and PG students who have an electrical engineering background will be okay with the course. See, normally in all engineering discipline, mostly with some E background, they will have a basic electronics course and a basic electrical course. So once you have done that, you should be able to follow the course, because whatever is required, I will start from very basics. Like, let it be like a common emitter amplifier. That also will start from very basic. How a power electronics guy, we use a common emitter amplifier, right? So that will do. So like, you have to have some background on electrical engineering to appreciate the course. And the evaluation procedure, we will discuss it more once we start the course, but there will be assignment, quizzes and exams, and there will be markings, and based on that, you will be graded during the finals of the for the final grading of you will be based on this evaluation procedure. So I think I have come to the end. We can take up questions now. Mandeep, if I have missed something, you can add. Mandeep or Sumit, if I have missed something, you can add.
Mandeep sir, if you'd like to add something, please go ahead.
No, it is fine. It's fine. I would rather, focus towards the questions coming into the discussion.
Okay.
So you may, so I'm allowing the participants to unmute themselves and take up questions. So there are two ways to ask questions. Either you could put your question in the chat box. I'll pick them up and ask professors your question. The second could be that you unmute your microphone and ask the question directly to the faculty here. So anybody who's got any questions regarding the program, or if you'd like to know anything specific from the faculty, please go ahead.
Hi, Sumit, and hi, Mandeep sir, and hi, Santanu sir. So I'm Samyak. I'm basically I have around 2 years plus work experience in mainly in power delivery design. So I have been working on AI accelerator systems. Prior to this, I have also worked in Intel in client SOCs where I have worked on power delivery validation. So I guess this course is very relevant for me in upscaling. So my doubt is that in the flow of the course, will we develop any projects on building the ICs? Because I was more on the validation side, right? The main reason for me to join this is on learning on the design prospects. So, will we have like projects to develop the ICs at some niche level? How is the course? That is what I wanted to understand. Maybe the flow
Okay.
on that aspect.
Mandeep, can I take it up? Samyak, actually, we will be using LT Spice, right? So that will
Right,
be
right,
our so because that is free for all, right? So that is freely
right,
available to everything. So let's say I'll give an example. Let's say
right,
you have to design a gate driver. Okay.
right.
So what we will say is that these are the main building block of the gate driver. Now,
Exactly.
what is inside the gate driver is this is the MOS level implementation of those
Correct.
blocks, right?
Correct.
Up to
Correct.
that point, we will basically take. So after that, whether the like I can introduce you to TSMC processes, but I will not be very good at it actually. Okay, I can
Okay.
introduce that. Okay, but W over L ratio, like fundamental design, if you can do, and then this is how the block will look like. But because see, every company they will use a certain type of process. Okay,
Exactly. Exactly.
so that process I will not be aware. I can only tell you the basics of the design,
Right.
right?
Right. Right.
So up to that point, we will take you. So once from a MOS level, you know how to design, how to select the W over L ratio. So in MOS level design of a gate driver, you will see that there are many inverters, like digital inverters connected in a chain, right? So how do you select the W over L ratio of that chain? So that up to that point I will take. But now whether what process the MOS will be
No, 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 that is not
that
expectation. Yeah.
I will not be able to. We will not be.
Yeah.
Or
Yeah.
we don't have time also to cover that much, right? With the basics of the architecture, we can kind of take it.
Mainly architecture and the basic design aspects, we can get a good idea, right?
Very good.
Right. Yeah. Yeah. Thank you. Thank you, Santanu sir and Mandeep sir.
There are some questions on the chat box. Let me take it up. Irfan is asking. I'm okay. Irfan is not a Samyak. Samyak I just answered.
No, sir, yeah, these actually most of these are introductory side, like when we were starting.
Sir, I'll ask you the question, sir. Let me pick up the
Yeah, yeah,
question and ask you.
yeah.
Okay.
So we have Satish Kumar who's asking how to use VLSI in power electronics.
Oh, VLSI and power grid. Okay. So see, this control IC that I was talking about, that is actually VLSI. Okay. That is actually electronic circuits. Okay. Because a power management IC will consist of the power management IC is a mixed signal IC. It is not an analog IC because like the input is actually an analog signal because voltage or current is sensed. So that is an analog signal. But inside, whatever you want to do, you do. But outside has to be another digital signal which will be given to the gate drivers, right? So that you can switch the MOSFET on and off. So now this power management IC is actually a VLSI circuit. This is actually a IC, basically a completely a IC. Now that IC can be analog or digital, but we will be focusing mostly on analog ICs. Okay, because analog ICs are mostly used for application specific purpose. Like for example, if you have a certain application, so there is a difference between power management IC and generic IC, let's say. Generic IC like a op-amp or a comparator, they can be made for anyone. But now power management IC, it is for a specific purpose. Let's say there is a power management IC which will only be used in let's say a laptop charger. Okay. Now the input is a 230 volt, output is a 19 volt. So there is only one IC that will be there. Whatever is required will be inside that IC, and then they will make it a proper format. They will take the sense signal, and that converter, the PCB will be made, and that is actually going inside your laptop charger. That is one example. There is another example, can be your cell phone. Your cell phone has a power management IC inside it, which is actually powering your Snapdragon processor. Right. So, like I used to design things for, I was a server IC designer. So I was the designer of let's say Intel 16 core processor. So when Intel will say that I need this much power to be delivered to our IC at this voltage. So normally it is 1.5 volt to 1.8. So 1.5 volt is a standard number, and the current rating will be 40 amp, 50 amp, or 100 amp. I have designed for 220 amp. Okay, in application. But there, what we do is that then my input is a 12 volt bus, my output is a 1.5 volt bus. So my job was to design that IC. Okay, and then make a converter out of that. So just making IC is not enough, because the converter has to be there, the power stage has to be there, the controller has to be there. The controller will be the IC that I made, and they will be connected together to make the whole circuit work. So hopefully I answered your question.
Yes. Thank you, sir. So we'll move on to the next question, sir. So Abhishek Kumar is asking two questions. So placement support in the industry. So he's asking, once I complete this course, will I get placement support in industry, and what are the projects you will cover in this course? So first part I will answer, second part you may answer, sir.
Yeah, please.
So Abhishek and the participants who are attending, so this, as I told in the beginning, that this course program is designed to give impetus to the semiconductor mission of Government of India, and with the support from the PSA office and DRIIV, we are actively engaging with industry and companies to make them interested in recruiting the program graduates from this particular course program. In this pursuit, actively we are reaching out to various semiconductor clusters in Bangalore and other parts of the country, and we are networking with companies, and many of the companies have shown interest to even nominate their employees for the program, as well as recruit from this particular program. So we are very hopeful and very confident that you would be able to secure a good placement after this course program. The second part of the question, sir, what are the projects you will be covering in this course program? Abhishek wants to know.
Okay, so specific things that we'll be covering is what is inside an IC. Like, what are the building blocks? That will be your project, right? So let's say the building block is a gate driver. Let's say the building block is a PWM controller. So these are your building blocks, and that will be your project, because all these projects will ultimately get together to make the IC, right? So step by step, we will be developing each and every block, and in the end, the complete project has to be demonstrated that with all these things, the power converter is working. Of course, you have to do it in LT spice. So that will be so once you know that, you can, once you are done, once you are comfortable with one design, then the similar design for other converters you can actually do. So that will be the
So Sharan Kumar is asking a question, that he is actually a ASIC post-silicon validation engineer, where he validates LDO circuits. Is it possible to switch his career from validation domain to analog design through this particular course program?
I think that you are in the best position to, because if you are doing LDO, like LDO is a non-switching circuit, right? So switching circuit, like if you look at inside an LDO, what is there inside an LDO? There is a PMOS that is there, and then there is a like a op-amp that is like basically regulating your output. So you already have two building blocks that are common to your power management IC. So once you know how to design that, then it's just the extension of your studies. And because you are more comfortable in validation, So you will be better, you will be able to better appreciate what is going on in the power management domain, which is a switching circuit. So to answer your question, yes, of course. I mean that. I mean, to me, if I were you, I would be very comfortable with what is being discussed.
Okay. Sir, Kaushik Nath is asking a question for an electronics and telecommunication engineer who has validation experience of locomotives, power converter. Is this course helpful?
Uh, depends on what you want to do, right? So already you have a job where you do power electronics, right? So this course will expose you to IC aspect of a power converter design. Okay, so ultimately, like Sumit correctly pointed out, that actually this course has been, we have been asked to give this kind of offer this kind of a course, and we have been asked to keep the value low, right? So the price low. The reason is that, see, India is going towards a electronic industrial hub. Slowly it is going towards that. So this course is basically exposing you to the IC aspect of any kind of power converter design. Okay, so if that that is okay with you, that I don't know whether you want to do that or not, but that is what the course will do. It will expose you to the IC aspect of power converter design, and it will do so from a power engineer perspective. So if you are a power engineer, you will be very much able to follow what I will be saying, because I am a power engineer by profession, right? So I am a power engineer who has learned VLSI, right? So that is it. Mandeep, you want to add something?
Yeah, a few line maybe here. So see, what happens is there is always a role changing. You are in validation certainly, but as soon as you try to move to design perspective side of it, let's say you are designing a power converter only, even a power stage. In industry, we don't design the full converter itself by one person. So understanding of this supporting electronics around the converter and their ICs, how they will behave under certain conditions, it helps a lot when we do that. Even in validation side also, if something is malfunctioning, something is not responding the way you want, uh, you may have a proper guideline to diagnose it. If this particular problem is coming, it might mean something in that region, it is a problem. But when you understand each and every IC, their internal working, their behavior when they are going in and out, then you can really pinpoint the issues with much more efficiency. So this is where it helps, as well as it increases the exposure into something which is certainly going to be a major portion of industry in coming days in our country. So that is what I want.
Thank you, sir. Thank you. So I'll take up the next question. Prashant, I think we've answered your question, which is on that. Prashant was asking, I'm a hardware design engineer. Is this course helpful to design converter section? How much it will progress for me?
Right from, so like we will be going in, right, like from the converter to what are the components of the converter, to where does the IC fit in, to how do you design the IC and how do you implement the IC. We are actually going through the whole chain. So I will kind of believe that will I mean, if because see, this course will integrate. If you are a power electronics engineer, it will integrate you to IC design. If you are an IC engineer, it will integrate you to power electronics. So this course will be a very good bridge between them, because I keep telling you that the way we have formulated the course is not based on some book or anything like that. It is based on personal experience, okay, of me and Professor Mandeep, right? So we know what exactly is needed to go from an IC to a converter. Okay, so that is precisely what we will be doing.
Sir, I'll take up the next question, sir. Amit Pandey is asking, I'm a mixed signal design engineer, designing ADCs and DAC. Will this knowledge be helpful there?
If you are just like, see, if you are thinking about ADC and DAC, so they see this we will be covering analog ICs. That is for sure. So the knowledge that we will be providing you is how do you take a signal from outside, process it, and provide a digital signal as a controlling signal to a converter. Okay. Now, what is inside this IC is what we are talking about. Now, you can actually, I won't know much about based on what you have written, I won't know much about what exactly the application you are intending for. But if you are trying to get into power management circuits, then this is a very good opportunity for you.
Thank you, sir. Sir, Naveen Kumar Mangalpali is asking which EDA tool we are going to use in this course program.
For simulation, we'll be using LT Spice because that is free for everyone. That is because any special tool I have to use, we have to have license for that, right? So that we will not be doing. We will be going through standard if that is the question, then we'll be using only LT Spice.
Sir, Satish Kumar is asking, quantum computing systems gradually increase this time. It's quantum, no. Satish, you'll have to clarify your question. Not able to make sense out of it. So Trivikram Prasad is asking, my background is mechanical engineering in BE plus additive manufacturing in PG. But I've done internship and now I'm working as employee in thermal management for semiconductor. Now I want to enhance my knowledge. Can I get into this program?
Okay, so if you have some exposure to electrical engineering, you will be able to follow the course. Okay, so that Trivikram you have to basically decide now. So this again, I'm telling you, this course will relate you to IC design and power electronics, right? So
Just I want to enhance the knowledge, that basic knowledge I need. That's it. I'm not expecting anything. Like my company, we uses the semiconductor. So rather than we are just, I'm in the design field of thermal solution for the semiconductors. No, I want to know the knowledge of what the semiconductor, how it works, what's inside it. I just want to know. That's it.
okay, so
Can I get in the?
Yes, yes. Trivikram, from a circuit perspective, if you are if you are talking from a circuit perspective, yes, yes.
Basically, without knowing the circuit, we cannot know about the thermal heat generation. So
Right.
that's what, sir. Just
Yeah,
I want to
so
know.
that you should be able to get out of it. Yes.
Sir, I'll take the next question from Bharti. So Bharti is a railway signaling designer. So she's asking, is this course helpful for my future career? So, sir, if you could, I'll just add on my part of the question also. So, sir, if you could actually explain its application in railways or upcoming mobility space, because we have a lot of people from this particular industry who are willing to take up this course program.
Okay.
So, including railways, if there are any good opportunities shaping up in analog and ESDM.
So, see, this is a very fundamental course. So, anywhere where you are transforming power from one form to another, you will require a IC. You will require a converter. For the converter, there will be an IC required to control it. So, let it be railways, let it be EVs. Let's say, for example, EV charger. Let it be a onboard charger or a fast charger. Onboard charger is inside the vehicle, fast charger is outside the vehicle. So both of them will require a power converter and will require its control. So for that control, you will require a IC. And what is inside this IC is what we are basically discussing. And that is common to all converter that you are having. The only difference is that how the inside the IC, how the ingredients are connected together. Like, for example, you are making dal or you are making sambar, right? So ingredients are the same. The vegetables are the same. The dal is same. Water is same. But the way you do it actually changes the overall taste. So someone who is tasting sambar is thinking that dal is completely different. But for someone who is used to cooking, they will know that they both are the same. Actually, they have the same ingredient, just done in a different way, right? So same thing is true here. All the ingredients inside the IC will be taught. Now, how do you connect them? Based on the application, you basically do it. Okay, so anywhere you have a power converter, you will need a controller, and controller will need an IC. That is what we will be.
Sir, I'll take up one more question here from Narendran, who's asking, my background is in EEE and I'm currently working as a telecom engineer focused in UE side layer 1. Would it be possible to transition into a power management role after completing this course?
You don't have to. Actually, in telecom, there are a lot of, in my presentation, I said that there are a lot of applications where power converters are used. Let it be UPS, let it be the power supply inside the server. Okay, so they use this IC design, these ICs. In fact, I was a IC designer for these applications. So in a way, like you are already exposed to where these ICs are being used. Only the course will do, what the course will do is that it will tell you what is inside that IC. Okay, so that, I mean, you have a better understanding of the application. All application you already know, what a better understanding of the system.
Okay, so sir, I'll take one question from Satish Kumar. So he's asking VLSI design or quantum computing, which course is best after 5 years of experience? Which path somebody should be taking? I believe this is what he's implying.
Okay, I don't know quantum computing. I'll tell you my experience. Okay, I'm trained in IC design and power electronics, and I came back to India in 2008. So when I came back, I worked on renewable power converters. After renewable EVs came up, after EVs, I can clearly see that hydrogen will come up. So I will never go out of business. Okay, so it is the same thing. I just have to change my shirt and just be, and Mandeep will share the same story to you. Okay, so like to be very honest with you, he worked on. Mandeep, you want to add, or should I tell what he worked on?
No, please. Sure. Please.
So Mandeep worked on EV chargers. Okay, to start with. Okay, then he did GE aviation. At some point, he also did artificial heart. See, everywhere he was actually exposed to smaller ICs, which were he was trying to control the converter, right? So you can see varied application, but it all fits in here, right? So I don't know much about quantum computing, and neither do I. I mean, my age is so I am advanced age that I don't think I can also learn how to do quantum computing. But I can clearly tell you that if you know this power IC and power electronics, you will never go out of business, because people will need power in some form or the other, and they will need you at some point.
Sir,
So
I will
I would
Yes.
like to add one or two sentences here. So basically, quantum computing is also one of the very exciting field. There is no question about it, and coming up as one of the major thing in our industry also. But the thing is, right now we are not in the same stage where we are in IC or IC fabrication. You must have seen that since last 10 years we are fighting hard to have more high sort of IC infrastructure in India. Still, we are nowhere there. We are actually not manufacturing anything, but we are pushing towards it, resulting into much more industry exposure, much more job in that area. Quantum computing has just started. It is just starting in India. So it will take the similar stage to come at least 20 years in our country. So if you look at the coming career goal for our generation, I would rather select this field of IC design or that sort of area. If it is about my kid, I would go for quantum computing. That is a clear selection.
I think you simplified it very nicely, sir. Right. So, sir, one request I have, few of these participants are asking if you could elaborate upon the course curriculum, sir, which we are looking at. So I'm sharing the modules that we've planned for this course program, sir. If you could just give a run through that, how is this going to be, this course going to be, what all coverages this course has, what all we'll be covering, how we have constructed the program. So this will be valuable for the participants.
All right. So forget about the module. I will tell you what we will be doing. I will tell you an application in the first class itself. For that, I will design the converter in 1 or 2 classes. Then once the converter is designed, I will tell you these are the parts that are there in the converter. So once the part has been identified, will say that this is the part that can be implemented in IC. This is the part that can never be implemented inside an IC. Okay. And once we have selected what can be implemented in an IC, then we will go through what are the blocks that will be required. So in order to understand the blocks that will be required, you have to have a understanding of the feedback system. So whatever is required, when and where, I will be telling you. You don't need to read any book or anything. My course will be like our course will be actually sufficient for that. So now once we have decided that these are the blocks inside an IC, then what is inside that block? So in IC design, there is a proper methodology of designing these blocks. Right. So see, this proper methodology is what we will be kind of taking care. So what are the building blocks of an IC? How do you connect those building blocks to make a circuit? Like for example, if you are from IC VLSI design field, so what is a current mirror? What is a current steering circuit? What is a biasing circuit? What is a differential stage? So how are these put together to make a differential op-amp? Is one by one we will be going towards that. So like I said, we'll start from the application, then slowly go towards the IC, what is inside the IC. Now, once we have reached the pinnacle, we reach the end of that IC design, then again we come back with those simulation models that we have developed and see whether my converter is actually being properly controlled through that IC or not. So this is what the course will basically cover step by step.
Okay. Sir, I'll take one question from Shivam Srivastava here. So Shivam Srivastava says he had worked at IIT Kanpur as project engineer for 12 years and dealing with solar design and O&M. Currently working as FAE in Arihant Electricals. Will this course be suitable for him?
Who did you work with, Shivam, at IIT Kanpur?
Shivam, you could unmute and speak. Shivam Srivastav, you could unmute and share with whom did you work at IIT Kanpur? Let me unmute.
Okay, so I maybe he was from VLSI design, so that's why he was not aware of me. I was actually at IIT Kanpur for last 16 years. So in VLSI, if you have taken courses, I don't know whether you are from VLSI or not, but assuming that you are from VLSI, you would have taken courses by Professor Majari or others, right? So basically, I'm talking about people who teach circuit related courses because there are professors who will teach device level courses like Yogesh and others, right? So circuit level courses, if you have taken, so when Professor Majari will teach, he is actually a traditional VLSI designer. So he will not be aware of power converter. I mean, maximum he will be aware of is a class D amplifier, which is again a buck converter. So now, but his knowledge of VLSI design will be absolutely perfect, but the picture perfect. The way the Professor Bajari teaches is wonderful to basically listen to. But the idea is that he is only a IC design professor. But what you will learn in this course is that there is a bridge between power electronics and IC design is what we will be kind of learning here. Does that answer your question, Shivam, or?
I think, sir, it does. Okay. So, sir, I think we've covered most of the points which were there in our brochures. So, I'd just like to add one or two points from people who are considering this course program. So, as Dr. Mandeep and Professor Shantanu shared about the program, that we've tried to build up a program based on experience and not on the basis of various textbooks and courses available. That's the first differentiating element of this course program. The second one is that I believe if you do a Google search, which I am sure that you would have done, you would find courses which are being priced upwards of 2.5 to 3.5 in this very domain of semiconductors. So this has been a convergence that we've had with DRIIV, Government of India initiative, and Dr. Shantanu, that we would like to keep the value of this course program affordable, so that more and more engineers could afford it and actually do not have to be in pressure to learn about this new field. So you could go out and search this. So the second differentiating element of this course program is its price. So we priced it very aggressively in the industry. So we priced it around 55K is what we have looked at, and I'll share the details with you so that just a moment, sir. Yeah. So as you could see the program, so we've kept the course program fee at 55,000 plus GST. There is a registration and application fees of INR 2,000 to be paid at the time of registration. So I believe few of you would be already engaged with our academic advisors. So there is an installment schedule that we have put in the course program. You can register for the course program, and once an offer letter is issued by DRIIV to you, signed by Professor Santanu Misra and officials from DRIIV, you need to pay your first installment of 15,000 plus GST immediately after the offer letter is issued, and remaining 20,000 after 45 days, followed by another 20,000 last EMI of within 90 days of the class commencement. So this is the affordable method that we've been able to figure out to help you realize your dream in the semiconductor space. If you have any questions, queries, you could contact the counselor, and we will also be sharing the recording of this particular session for your review again. You could refer it. If you have any follow-up questions, you could email it to us, and we'll get them resolved in our next faculty meetup, or through email, we'll try to resolve it. So if you have any other questions related to the program, please feel free to ask. We can take up more questions. We've got some time.
Hello, am I audible?
Yes, please.
Yeah, hello all. So my question is regarding so currently I am working as a physical design engineer in ST Microelectronics. So I've also done my MTech Masters in VLSI design. So is this course help me to build career in analog and power management ICs? So actually I am working in stock digital physical design engineer. So will this course help me to build career in analog and power IC design?
Yeah, of course. Yes, of course, right? You are a digital designer. So this course will expose you to analog design. Analog design are ASICs, application specific ICs, which are low cost, right? So any kind of application where the cost is very sensitive thing. So there people will tend to use a single IC, where that is what we will be basically designing in this particular course. So Mandeep, you want to add something to it?
I think it's fine whatever you said. So basically, that's like you are designing in digital domain, and as far as I understand, the digital design procedure is significantly different than the analog side. So are you using FPGA sort of design procedure, or some other methodology?
So here we are not FPGA, S6. We are building S6.
Okay.
S6, okay.
Okay, 6. So basically, these designs which we are talking about are more or less on the circuit side of the analog. So they are fairly different than the digital. You will see they are not going into just zeros and ones domains. It's fairly in between in amplifier zone and all those we are working. So it will help you. Certainly, it will help you in that direction.
Okay. Any other
Yes, okay.
questions you'd like to ask? Anybody who has any other question?
Hi, this is Yuvraj. I'm
Yes,
working
Viraj.
as a
Yes.
I'm working as a packet design engineer that called like a substrate design engineer in Intel, where after silicon, where the package that means BGA or FPGA will design, right? So I'm the designer. So how it will help me in the career, this course?
I think just now Mandeep showed that thing. So package is the next step to, so we will bring to a place from where you take over, right? So we will bring to a IC with pin definition, what is inside an IC. Up to that point we'll bring, then you take over from there, package as a package engineer, right?
Yeah.
So therefore, knowing what is there inside the package will definitely broaden your scope, right?
Yeah. So one more question. See, where like a small ICs, power ICs, okay, where it's coming. That is called wire bond technology. They'll use, correct?
Yes.
If you correct me. So where some of the power ICs with the QFN type or BJ type also nowadays is coming, power
Mm.
ICs.
Mm.
So you will also teach us those kind of things or only the uh,
Up
like
to the IC I will take. Up to the IC I will take. Because see, if the,
okay.
it is whatever I'm saying will also take significant amount of time, because you can understand that we are coming from a basic electrical to a final IC. See,
Yes.
in the beginning of the course, you are going from basic electrical electronics to a final IC. All right. So in a 6-month course, we will be able to cover that. But after the IC has been like defined, the next task is layout of the IC. Layout,
Okay.
after that, it is like the manufacturing of the IC. Okay. And after the manufacturing is done, it is cut into small pieces and it will go to you, where you will put it inside a package. Let it be a BGA package, let it be a SOC package, let it be a, let's say for MOSFETs and things like that, a D pack or D square pack. So there you put the IC and then bond it, right, with gold bond, right? So that part we we cannot, I mean, we are going till the design part of it. From there you
Got it.
take over, right?
Okay. Thank you. And thanks for bringing such kind of course in India. Really is I'm seeing first time in past 10 year, and thanks for this, because some people want to know secure the job or they want to deep in the technology. It's not related also. I'm doing a packet design. When I'm doing is just we'll ask a power IC guy that what are the input, output, and RTC value, R path, how much I need to achieve. More than that, we'll not ask. R path to achieve, yes, you'll definitely power going to deliver. Now you're giving such a knowledge. It will definitely help. Thank you so much.
It comes from our from my industry experience, that like my job was to define the IC at IR, International Rectifier. It became Infineon after that. So I was in the task of, let's say I am saying that you have to use a op-amp here or a comparator here, which are basically put together inside the IC. So the designer will ask me, what is the gain bandwidth product you need for this op-amp? What is the biasing current you can tolerate, right? So these are the questions that the op-amp designer will ask me, or the IC designer will ask me, and I have to tell him an answer, right? So I will say that 1 megahertz is my gain bandwidth. So then he will ask, why do you require 1 megahertz? So I have to prove to him that if it's not 1 megahertz, then in the overall converter control, it will not work. I had to prove to him. So what this back and forth process does is that it actually tells you whatever you are putting inside, why you are doing it. Otherwise, it will not even work. So this back and forth is not about the you put this one and this is how you design. No, that is not it. Like it is about more than that. Like, why did you do this? Okay, so that kind of, so that from that experience we are bringing this kind of course.
Thank you, sir.
Thank you, Yuvraj. Thank you. Any other questions, participants? So I think, sir, there are no more questions, so we can conclude the session today.
Sir,
Thank you so much.
sorry again, Yuvraj. So for taking this course, anyone have a experience of 10-year experience with a diploma, they can also can take, or how it is, sir?
If they have, so you need to have a sufficient background in electrical and electronics. Because see, once we start the course, now if someone, I am telling that this is, I will do a KVL here. Okay, Kirchhoff's current law or voltage law. You cannot be asking what is KVL to me, right? I mean, and then I will say that, okay,
No,
this is Ohm's law.
my
So some
question is
basics have
like,
to be there.
yeah, basic to be there, like a diploma person can also apply
Yes,
for.
yes, Yuvraj.
Yes.
Yeah.
Diploma person with
Uh,
experiences are eligible to enroll in this program.
Yeah, thank you.
Right. Okay. Anybody else who would like to ask any questions? Okay. So thank you, Dr. Santanu Misra. Thank you so much, sir, and thank you, Dr. Mandeep Singh Rana, for your valuable time to spare with us in order to guide our prospective candidates and students. And we look forward to seeing most of you into our course program, which we hope to start shortly. And if you have any follow-up questions, please feel free to write to us or contact us. So I'll just share where you could actually download the brochure. So let me. So you could go to Railway Academy. I'll just share the website also. So you could actually go here and I'll just could go to this particular website in the executive and university programs. You could download the program, and additionally, we will also be sharing the brochure link in our email to you with the recording of this particular session, so which you can access it and know further about the program. So I will conclude the session right here, sir. Thank you so much again for your time, both Dr. Shantanu and Dr. Mandeep. Thank you for taking out your time. And thank you, Varunji. Would you like to say something? I think Varunji has left. So, yeah. Yes. So we have with us Mr. Varun Raj, who's been very instrumental in actually bringing this collaboration into this place. So he's the one who has coordinated with DRIIV and IIT Delhi CART, Shantanu sir, Mandeep sir, and also PSA office to actually formulate various thoughts and expertise into this course program. So I would invite Varunji to please conclude.
Thank you, Sumitji, for letting me in this great discussion. I was very keenly listening to Professor Shantanu Mishra's and Dr. Mandeep Rana sir's detailed discussion on this the details of this course. I have already. I'm basically a trained VLSI design engineer. Shantanu sir knows about this, and I have spent a lot of time, more than a decade, in companies, including government defense companies and also IC design companies. But this power management IC design is really a very interesting area in which even I am not very much aware of. And with today's discussion and the elaboration, I'm pretty much sure that the gap between the traditional VLSI designers and power electronics engineers, that will be surely be bridged with this particular course. And the kind of job opportunities which are coming up, especially in companies like Texas Instruments, Analog Devices, and also in Intel,
this will be a great course to attend. And in fact, I would like to uh, uh, add that the PSC office is also in touch with these companies, and to so that the successful candidates, so the people who graduate with this course, they get an opportunity uh, for to land to land in these companies for the various roles, and and also I, hello, am I audible, sir?
Yes, sir. Yes,
Yeah,
sir.
yeah, yeah.
Yeah. So the PSA office and is also working along with the companies, and we are trying to get some kind of sponsorship also. So this will be a very good course for all the students who are entering the field of VLSI design, and also who have a prior experience in validation or in a simple digital design flow, or a simple power electronics. So this course will be an actual amalgamation of all the high tech, so to say, the expertise. So encompasses not only the VLSI design, but also in-depth analysis of the power electronics. So that will be a this. I'm very sure that the students who will attend this course will have a very great future ahead.
Thank you, sir. Thank you, Varun, sir. Thank you once again, Shantanu, sir, and Mandeep, sir. Thank you for your valuable time, and
Thank
have a
you,
great
sir.
evening ahead to everyone.
Okay, bye.
Thank
Thank
you.
you. Bye.